Hello everyone, this is week 4. This week we will have two parts of lectures. The first part is dataFrames in Spark. The second part is SQL in Spark. So for dataFrame, which is this part, we will cover the following. What a dataFrame in Spark look like, how to create data frames from different ways from different sources. And we will also going to look at functions and methods Pandas has provided for us to analyze data. And also we will understand a structure and the strategy of data frame and comparison with other methods. The first one is what is data frame, which is a single Python object with rows and columns, which pretty much like spreadsheet, Excel, or table, relational database. So in relational database or spreadsheet, in most cases, we have many rows. Each row represents a record which has the values on different attributes. So each attribute is represented by a column. So in one column, for example, student ID, for that column, all values in every row are student IDs. And the data frames can combine into a single one. And the data structure format is defined by schema. We will see later on how are we going to define the schema. So schema is kind of definition similar to SQL table definition. So when we create a table in SQL for relational database, we have some structure or syntax how to create data. So there are many ways to create a data frame. We will have a look at the example from different ways. So for example, this is a list of many ways of the source data. So they can all convert to data frame, Spark data frames. So some of them from existing relational style storage, or some of the CSV file and JSON file. So and also relational database. So they all can convert to data frames. So the structure is columns, attributes, and different rows, which is records. So probably we start with this slide. This slide creates a data frame which directly insert records in a data frame. Okay? So in this example, we have one data frame which is about department. So I explicitly say each row. So I know is a row, and then I know the attribute, which is column, and I know the values. Okay? And also I know another variable, and I know the value of that. Similarly, I have second row, which have ID is attribute, name is attribute, I have value, which is quite similar to SQL's insert statement. So insert statement also specified variable name, the value to that variable for these records. And here is another example. So I have this is a different example. So I have a row. The first one is heading of the row. So I say this is okay. This is the attribute name, attribute name, attribute name, attribute name. So which is quite similar to Excel. So on the first row, normally you specified the attribute name, and then you defined this row, and you just put the actual value to corresponding attributes. So for this case, first name is Michael, the last name is Armbrust, and email and the salary. So this probably is quite easier than the first way. So, however, they still insert each record directly to the data frame. Okay. So this is another way to create a data frame. So we have already learned redundant distributed data set. We have called RDDS. Okay. So the schema is defined the headings of the table. In other words, is a list of attributes of the table or the schema of the table. So they are all the name of attribute on the list. Somehow similar to the way we use to define the first row. Okay. So normally are manually defined. So this data frame print schema, it just let us to double check if we have made this correctly. So this created from redundant distributed dataset. So the Spark, because we have seen a kind of Spark SQL and the data frame, we will look at the Spark SQL in later part. Just to give you very quick summary to compare SQL and the Spark SQL. So SQL, we know that we directly apply them on the data in relational database and extract information in most cases. For example, select something, and for example, insert statement, for example, create table, for example, join. These are the major functions we have used for SQL. Similarly, Spark SQL is similar way, but it operates on data frame. The difference is that in SQL, most of the time, they work not in parallel, but for the data frame, which have the parallelized ability in the Spark environment. So the data may be distributed to different places. So that is a major difference from SQL from the Spark SQL. You may also find the syntax are somehow different, but we will talk about that later on. So we can also create a data frame from structured data. For example, this gives us an example. This called read load. This is a function. So you can define the file name, format, how to separate the values, and then you defined if this one has header or not. Okay. Also, manually defined or you automatically recognize from the content. So different from normal SQL or relational database, data frame may be created a dynamic from other data frame in several different columns, and then from other data source. So this is how we are going to define the schema. So you will see schema is defined by this way. This is how we define it, and then we create this data frame, which is resilient database under the schema. Okay. Under this one, you may see two things. What is structure field? Okay, structure field and structure type are the classes we have been specifically designed for the schema. So they could create complex columns like a nested structure, and also the structure types has collective structure field. So we are going to see example on that later on. So for example, you can also do some operation. For example, data file have field function. So this data frame, if the rows has the value in that column, every row in that column is larger than 24. It's a condition we display them. So I know Excel also have some function. So on each cell you can select some value to certain value, and then you do some calculations. For example, also I make a smaller data frame from existing one when I apply this. So I filter my data on the current data frame whose attribute is age and whose attribute size equivalent to 10 and larger than 35. So this is kind of a filtering function in SQL for relational database. We can also use a select function and together with condition to filter our data set. So Pandas is a data analysis library for Python, and which is use I list a function in the next slide. This one is comparable with PySpark, but they also use single machine owning, so they have some limitations. So the main functions of Pandas are reading data, writing data, and they have a special way to handle missing data. They can also do group by, which is also the functionality is also available in SQL for relational database. And also they can do join, they can do a time series as well. Okay, so if we have a stop data frame, how can we convert them? So they have a function which has us to, so this is object of data frame, is a data frame. So I want to convert them to compact. So this is a function I use. For the another way around, we can also use create data frame. This is a function we have seen earlier, but in the input is Pandas. So they have support many different types, the Spark. We will later on see a diagram on that. Apache Arrow is a language-independent culinary memory format, which is quite generic, independent by the program language. So the purpose is to reach efficient analytical operation. So this will give you a diagram on different format. For example, we have pandas, we have Spark, we have HBase. So each system has its own internal memory format. The Arrow, Apache Arrow, which is language independent, which they can process different ways of a memory format. They all share similar function in terms of implementation. So pandas have some statistic method because the original aim to develop pandas is to analyze data. So they have a lot of function, but this list of the basic function, basic statistical method, mean, correlation, count, max, minimum, median, standard deviation. So we normally just need to use the function. So compare with dataFrame. dataFrame can run on different cluster nodes. So that is a distributed way to do the parallel computing. But however, pandas is on the single machine. And in pandas, the results are immediately. And as we have seen before, dataFrame is immutable. So we cannot insert update data. So pandas API support more operation than dataFrame. And because the purpose of pandas is for data analytics, that's why it provides more complicated operation. So there are more embedded functions available there. So this is kind of, in summary, strategic way of for dataFrame. dataFrame is mainly for large-scale dataset, so they can process in distributed way. They can also use a way to select certain data and select a subset to do the operation and to testing and develop the total result on the whole dataset. So this is our further readings on the dataFrame and also on Spark SQL. So the next part will be Spark SQL.